So hey, my name is Cass. I'm at MIT, advised by Dylan Hadfield-Menell, and I'm excited to chat a little bit about generalized adversarial training and testing. The motivation for all of this, I think, can be expressed largely by how we keep observing the language models are really, really good sometimes at things that we try very hard to make them bad at. My favorite example of this is the most cliche one that's kind of out there. That's that red teams have found a really consistently different wide variety of techniques for getting instructions for building bombs from modern state-of-the-art safety-aligned large language models. That's something that every one of these papers up here does, specifically getting instructions for building bombs. And this is really an ongoing process. A new development has come about a week ago when FAR.AI released their SIGNet model. And SIGNet is awesome, state-of-the-art, like very, very robust. But that didn't stop red teamers from within about a day of the model's release finding some very simple prompting strategies that were able to get instructions for building Molotov cocktails from it. So we seem to have on our hands a classic like smiley shoggoth situation where we have techniques like RLHF that are really, really good at kind of putting a smiley face on the monster and making models behave quite nicely in most typical situations. But what they do not seem to be good at is removing these latent capabilities very deeply. And we see these capabilities resurface and cause harm pretty consistently in the face of anomalies or attacks or modifications to a model. The way I like to think about this problem as someone who works on red teaming is in these terms. So we have these language models and there are many, many possible inputs for them. The input spaces are like beyond hyper-astronomically large. So we're never going to be able to ensure that they're always safe or almost always safe by brute force enumerating over the input space. Instead, we have red teamers try to use heuristic searches for relevant or important failure modes in the ways that are efficient. But we're always going to see this gap between failures that are identified by developers and unforeseen failure modes. So as AI safety people, we look at this problem, and one way to kind of characterize what we want to do is we want to take this gap and we want to, one, shrink it, and we want to, two, help ourselves infer how large it might be. And that's where generalized adversarial training and testing comes in. So generalized adversarial training and testing is trying to take a page from a classic safety engineering, from the safety engineering book. It's a really common principle in safety engineering to design and test systems in order to try to make sure that they are capable of withstanding stresses that are at least as strong and ideally stronger than they're meant to face in deployment. For example, in construction, buildings will often be built with a factor of safety of like 5 or something, meaning that the building is designed and ideally tested in order to withstand like 5 times the maximum load that it's designed to face under its maximum occupancy. So what's the analogy with AI and large language models? I think we're starting to see and are going to continue to see a lot more work on generalized attacks, specifically like model manipulation attacks, where a model is evaluated under small perturbations to its activations through latent-space attacks and small perturbations to its weights through few-shot fine-tuning attacks. And I want to take the next few slides to just chat a little bit about some past, present, and future work involving latent adversarial training and generalized adversarial testing. If you like this little logo for latent adversarial training, come find me because I have like a bunch of stickers with it. So some past work that I've done with collaborators is focused on untargeted latent adversarial training. And we released this in February, and we were able to find some nice results in which latent adversarial training gave models a much more generalizable type of robustness than adversarial training alone. As far as present work goes, on Tuesday, a paper is going to drop on arXiv on targeted latent adversarial training from some more collaborators and I. And in this case, we try to apply latent adversarial training in a pretty diverse way to improve progress on some important problems. One of which is making models more robust to jailbreaks. Kind of one of the top line results here is that we're able to use targeted latent adversarial training to beat R2D2 with like 35 to 750 times less compute, depending on what compute measurement criterion you use. Another thing that we do is try to remove backdoors without any knowledge of a Trojan trigger. And we're able to do this fairly successfully. And the results from our paper are about as encouraging as they could be from the perspective of latent adversarial training being a solution to the sleeper agents problem, which Anthropic posed earlier this year. So that's pretty nice. The third and final thing that we do is do more effective unlearning with latent adversarial training. And we're able to strengthen some existing techniques by adding LAT to them, but we're also interestingly able to find that LAT confers better robustness to relearning these techniques through few-shot fine-tuning afterward. As far as future work goes, what I'm working on next involves linking generalized and input space threats. Specifically, I'm doing some work with Zora Che and other collaborators in order to test the hypothesis that robustness to latent space and few-shot fine-tuning attacks can predict robustness to hard-to-foresee input space threats. So if you're interested in this, find me and let's talk about it. I want to say thanks to everyone, and let me know if you want a sticker, and let me know if you want to see a Google Doc explaining our current work and project on generalized adversarial evaluation. Thanks.